Breaking news. TJC's eTHINK Challenge is back. Good morning, and welcome to Temasek JC's eTHINK Challenge Finale 2021. I'm Jaden, and I will be your newscaster for today. It is lovely to have you here today on this very exciting morning. Now, to take you through more insights on the eTHINK Challenge this year, I will pass the time now over to Awei. Over to you, Awei.
Thank you, Jaden. Hi, this is Awei speaking. The eTHINK Challenge was organized to allow participants to experience and explore real-life method of scientific learning firsthand. A mystery toolkit was delivered to your school and you were given the task of creating a short video based on your prototype, which would help to explain the concept of light. As efforts for sustainability in the environment becomes increasingly important in today's society, students were recommended to use recyclable materials. Up next, we have Celestine.
I'm Celestine. Are you interested to know more about our Temasek Academy activities and the eTHINK Challenge itself? Well, they will be coming right up. But first, let us proceed with a little teaser on what the 6-year IP program is about.
Temasek Junior College 6-year integrated program emphasizes more on collaborative and problem-solving skills as well as hands-on learning, in addition to the content knowledge taught in the classroom. In particular, the TJ IP Science program is centered around the eTHINK cycle pedagogy, incorporating inquiry and problem-based learning into its curriculum. It comprises of 5 elements: trigger, harness, investigate, network, know. Let's go back to Jaden.
Now, I'm sure many of you are excited to get on with today's schedule. But first, let's go to the general office to meet our school principal, Mrs. Lowe, to address us. Come along!
A very good morning to our Primary 5 and 6 participants, primary school teachers and parents, and TJC teachers and students. First, I would like to thank all schools and teachers for encouraging your students to participate in the 2021 eTHINK Challenge. I'm so happy that you can join us on a Saturday morning to celebrate the finale of the eTHINK Challenge. Despite many new challenges that we faced during COVID, such as considering many SMM measures, TJC hopes to continue to provide our primary school students the platform and opportunity to develop their curiosity in science, to explore experimentation and explanation of scientific principles and concepts in the annual challenge. This year, we have a total of 20 schools with 140 primary 5 and 6 students who have participated. I would like to thank our IP Science Department teachers who have guided our IP4 Temasek Academy Science students in organizing the challenge, and it is the 14th eTHINK Challenge. And to our IP4 Temasek Academy Science students who helped to organize this competition, you have truly demonstrated your innovation and your leadership skills by overcoming different difficulties. I'm sure that this will be a defining and memorable part of your TJC journey. Finally, to our primary 5 and 6 students, you have really shown your passion and interest in the learning of sciences by participating in this challenge either after your PSLE or immediately after your end-of-year exams. I hope you have enjoyed networking and learning together with our TJC students as you ask questions via the online platform. I wish you all the best as you find out the results of the competition later. I'm sure that your passion in science will continue to grow. I also wish the primary 6 students here the very best as you will be receiving your PSLE results soon. We do hope that you will join the TJC integrated program in 2022. Thank you.
Thank you, Mrs. Lowe. Next, we will have the HOD of IP Science, Mrs. Chan, who will share with you more about the TJC IP Science curriculum.
Good morning to Principal Mrs. Lowe, fellow TJC colleagues and students, and most importantly, our primary school science teachers, students and parents. Welcome to the finale award ceremony of the 2021 eTHINK Challenge. This year, we had a total of 140 participants from 20 primary schools, and they are Thank you to these schools for encouraging your students to participate and continue the joy of learning in science. Our primary 5 and 6 participants have received the Challenge Mystery Toolkits by 31st August and networked with our IP4 Temasek Academy science students via the online platform earlier before they submit their videos by 1st November. Next, let me introduce the different subcommittees who have organized this competition for our primary school students. If you want to know more information about the TJC integrated IP science curriculum and science enrichment programs, you can refer to the TJC website. You can watch some videos on the science events too. I look forward to you joining the TJC family in 2022. Now, I will hand the time back to our MCs. Have a great time with the upcoming items. Thank you.
Thank you, Mrs. Chan. We have received many exciting videos with interesting prototypes from all of you guys. Now, let us learn more about the theory of light from our explorers.
So firstly, we are going to talk about reflection. Have you ever wondered why when you look into the mirror, you are able to see an exact replica of yourself but laterally inverted? This is because of something known as reflection. We know that light rays allow us to see objects after light is reflected from the surface of the object into our eyes. The law of reflection states that the incident light ray, reflected light ray and the normal at the point of incidence all lie on the same plane, and the angle at which light ray hit the surface or angle of incidence is equal to the angle at which the light ray is reflected from the surface or angle of refraction, as shown in the diagram on the right. When parallel light rays hit the surface of a plane mirror, they are reflected in only one direction, as they have the same angle of incidence and angle of reflection, as shown on the diagram on the right. This is something known as regular reflection. So what are some characteristics of images formed in a plane mirror? Firstly, the image formed is the same size as the object. The image formed is laterally inverted or left-right opposite. The image formed is upright as they are not slanted or upside down. The image formed is virtual. And lastly, the distance of the image from the mirror is equal to the distance of the object from the mirror. So next up, my friend will talk about refraction.
Now, I'll be talking about the refraction of light. What is going on the image on the left? It looks like the bird is cut into half. Similarly, on the image on the right, it looks like the straw is bent and is cut into half. Well, this is just an illusion and it's due to the refraction of light. As light travels from one medium to another, its speed changes and the light rays bend. The laws of refraction, which state that the incident ray, refracted ray and the normal at the point of incident all lie on the same plane, and the laws of refraction enable light to be refracted from one medium to another due to the change in speed. Due to the principle of reversibility, light can travel through a medium and return through the same medium along the same path. This explains why these two images look like they're cut into half, but this is merely just an illusion, and as explained, this is due to the refraction of light. Look, a rainbow! Wow, isn't it cool? Well, do you know, this is due to the phenomenon of refraction of light.
Next up, I will be talking about the intensity of light. So for the intensity of light, we are looking at something that's called the inverse square law. Simply put, if your light is coming from a point source, it is radiated outward evenly in space. So you can think of this as part of a sphere, which will have varying radii. So as the emitter light travels a longer distance, the same amount of light will be spread out over a larger area. Hence, this will cause the light to get dimmer as it travels a longer distance. So this can be depicted on the diagram on the right. So with that, we have come to the end of our presentation, and I thank you all for listening.
Welcome back. Light is really cool and its applications are amazing. We hope you had a great experience tinkering with the Mystery Toolkit too. Now is the moment you have all been waiting for, the award presentation ceremony. We wish you all the best.
For Honorable Mention Awards, here are the winners.
Tan Kai Kiat Zachary from eTHINK School, Gan Jia Ling Abby from Hakel School, Isabel Claire Theolico Lee from Hakel School, Go Chen Xuan from Kranji Primary School, Nur Sarah Sophia binti Muhammad Izhar from Kranji Primary School, Kane Shao Hong Kai from Mahabodhi School, Vulapali Srivats from Opera Estate Primary School, Josh Lam Kai from Red Swastika School, Gail Ng from Singapore Chinese Girls Primary School, Ong Hee Swan from St. Hilda's Primary School, and Sophia Abdul Aziz from St. Hilda's Primary School. For bronze awards, here are the winners. Jaden Chua Wei Zi from Zhongfu School, Zenith Ko from Zhongfu School, Elena Vijaya from Hakel School, Mei Yu Han from Red Swastika School, Han Su Yang Caleb from Red Swastika School, Hayden Guan from Sengkang Green Primary School, Angela Hon Mao Sin from Singapore Chinese Girls Primary School, Hung Jun Kai Ryan from Tao Nan School, and Tan Jia Jin Kenneth from Tao Nan School.
For silver awards, here are the winners.
Mo Kai Sheng from eTHINK School, Jake Ho Shi Tie from Bedok Green Primary School, Ko Zi Tie Benjamin from Zhongfu School, Gong Zheng Si from Geylang Methodist School Primary, Pang Xian E Isaac from Geylang Methodist School Primary, Liu Peng Fei from Marymount Convent School, Quick Heng Wei Lucius from Maristella High School Primary, Wang Ji Q Alexander Kazuaki from Maristella High School Primary, William Tay Kai Shen from Ngee Primary School, Janelle Ang E En from Sengkang Green Primary School, and Tan Zheng Kai from Tao Nan School. Before we reveal the Gold Award winners, we would like to introduce one of our alumni from Temasek JC Integrated Program who would like to give you an insight on the future opportunities in science. Cedric is an A-star National Science Scholar who graduated from the University College London with a Bachelor of Science in Molecular Biology degree. He has attained stellar results in his undergraduate course, placing top in his cohort, and was nominated for both the Faculty Medal and Dean's List. He is currently a data scientist attached to the Genome Institute of Singapore, where he is working on characterizing the blood microbiome. His research interests include computational biology, machine learning, and infectious diseases. Over to you, Cedric.
Everyone, congratulations on completing the eTHINK challenge. The main topic for this year's challenge is light, which is something we take for granted in our everyday lives. For me to record this speech, light is refracted off the glass of the windows in this room and is reflected off my face and then captured by the camera lens. At the same time, the light that's being emitted by your computer screens is what allows your eyes to process the shape, color, and depth of my face. And when you think about light in this way, you'll realize that the technology around you harnesses the power of the theories and concepts that you have learned throughout the eTHINK challenge. And in the process of producing your submitted videos, you're forced to think about what you see or have seen in your everyday lives and how these observations can be used to explain the properties of light. The whole point here is a key part of what science is. As a scientist, I'm always observing the natural world and I'm always wondering how it works or how it happens. And when I get curious about something, I'll go search Wikipedia, scientific journals, YouTube, or whatever other resource to learn about for example, how a camera works, or how come the sky is blue. And if nobody knows the answers to the questions I'm interested in, I plan and carry out experiments to figure it out all by myself. And this is what I like about doing science. I get to learn about the world, how it works, and how to change the world for the better. Looking back, I was glad I studied science in school. When I was a student at Temasek Junior College IT, I took triple science, which is physics, biology, and chemistry. And in school we learned about many things, some of which were super boring, like who cares about the freezing point of water or that plants have chlorophyll. But as I learned more, I realized that these boring things that my teachers taught me gave me a good foundation to understand the science of the world and the technology around me. I personally urge all of you to consider taking science-related subjects when you graduate and pursue the next stage of your education. At the same time, I urge all of you to think about the interesting things or the phenomena that happen in the world around you and do some projects outside of the school curriculum. I'm sure your teachers will be very supportive of guiding you through these science projects. At Temasek IT, I had the opportunity to do many of these projects, which helped me apply what I've learned at school to the real world. I remember walking through the mangroves at Pasir Ris Beach, getting down and dirty collecting soil samples so I can learn about what mangrove soil is like. I also remember doing a proposal on how to clean polluted river water, and I had to make a plastic model of my idea. But because resources were so limited, I had to bend plastic using the fire of my mom's kitchen stove. That was pretty fun. And then when I moved on to my last year of JC, I had this research project where I worked on a new way to clean and disinfect vegetables from farms, so that I can use less chemicals while making sure that our vegetables are fresher and safer to eat. Well, these are some fun things that you can do and to expect when you learn science in secondary school, JC, or beyond. And I hope that what I've shared with you demonstrates how science can empower you to take charge and change the natural world around you. I also hope that this will inspire some of you to pursue careers in science and technology in the future. Thank you.
Thank you, Cedric. Now is the time you have all been waiting for. Here are the winners for the Go Awards.
Chase Teo Chun Si from Maristella High School Primary, Gauri Bergava from Marymount Convent School, Han Sun Ya from Mahabodhi School, Dania Yasmin binti Muhammad Hazlin from Opera Estate Primary School, Gandiwar Araf Raghavendra from Sengkang Green Primary School, Sonia Ruth Tan from Singapore Chinese Girls Primary School, Vanya McLaren from St. Hilda's Primary School, Gladys Chu Yi Wa from Townan School, and Skylin Loretto Jiongning from Townan School. Congratulations, everyone!
Now, did you think that was all the awards we were giving out? Here in Temasek JC, we encourage creativity and innovation. This year, we are pleased to introduce two more exciting awards. The Most Creative Thinker Award is awarded to the most unique setup and engaging presentation. The Enlightening Thinker Award is for the video with high educational value and clarity in explanation. And here are the winners.
The award for Most Creative Video goes to Gauri Bergava from Marymount Convent School. Congratulations!
How to use two objects then? Light from a light source strikes an object.
This experiment, I am using a torchlight and a mirror. An incident ray is a ray of light that strikes a surface, and a reflected ray is a ray of light that bounces off an object. Remember, the angle of incidence is always equal to the angle of reflection. See, actually, yeah, my brother jealous. So for this, you will need to have a hole the size of a magnifying glass, and then stick your magnifying glass into that hole. How do you go? I know. I think that's all clean. Now this is adjusted a bit lower. That's much clearer now.
And finally, the award for the Enlightening Thinker goes to Sonia Ruth Tan from Singapore Chinese Girls Primary School. Congratulations!
Hi everyone! Welcome to my Making Science Make Sense YouTube channel. This question is from 6-year-old viewer Titus. He asked, I'm a marksman. I can one drinking straw and a liter of water. Now, take a minute to observe the two setups. Do you notice any difference? Filled with water, the target board seems to be floating and it looks closer to our eyes. Next, look at the straws when spent. What's the reason? Remember, when you see something, you're not actually seeing the thing. You're seeing the light reflected off that. What is refraction? Refraction is whenever the light travels through one medium to another, meaning it goes from one material to a different material. It bends. That could be going from looks like I aim at the bullseye, but when I tried hitting it at the water, woohoo! Here's another experiment on refraction you can try at home. Pretty cool, right? I will explain it in my next Making Science Make Sense episode. Stay safe, stay curious.
And with that, we have come to the end of eTHINK Challenge 2021. Congratulations to all prize winners and thank you all for taking part in our eTHINK Challenge this year.
It was very inspiring to see so many young and budding future scientists from all the videos that you have submitted. I can see a spark in you guys.
Now, even though the challenge has ended, we hope that the pursuit of science and scientific knowledge for many of you here has only just started. The certificates are already on their way to your schools. Your teachers will be receiving them by next week.
Before we go, we would like to express our appreciation to our lovely sponsors. Thank you to the college leaders and teachers who have supported us in organizing this event. But most importantly, thank you to all participants who have worked tirelessly on all your submissions. We hope to see you again in 2022. Till then, thank you for tuning in and we hope to see you next time on our broadcast.
Thank you and see you next year!